This video is for D9 atomic spectra. This is an energy level diagram for an atom. In fact, this is approximately equal to the hydrogen energy diagram. A hydrogen atom has a single electron, and that electron can sit on any of these energy levels, but it cannot exist between them. When an electron is in the bottom energy level, this is called the ground state, n equals 1. You'll notice that the energy associated with that energy level is negative. And that's not an accident. That's because I would need to give this electron 13.6 electron volts of energy for it to have 0 electron volts of energy. And if I were to give this electron any more than 13.6 electron volts, then it would have more than 0 electron volts of energy. Let's give the example that I somehow gift this electron with 14.6 electron volts of energy. The electron has absorbed this energy and it can now move up to an energy level, well, there's no energy level there. It can move to an energy above this 0 electron volts. In fact, it has 1 electron volt of energy. That is the energy of this electron. It is its kinetic energy, 1 electron volt. If the electron were given any energy less than 13.6 electron volts, then it would not be beyond this dotted line. The electron would still be bound to the atom. It would have less than 0 kinetic energy. It would not be free. So we call the ionization energy of this atom 13.6 electron volts. Now if the atom were to be in an excited state, as you can see here, and the electron was allowed to fall to n equals 1, then there would be the emission of energy, as the electron goes from negative 1.5 electron volts down to negative 13.6 electron volts. So the electron, without stopping in between, goes from n equals 3 to n equals 1. The final energy of the electron is negative 13.6 electron volts. The initial energy was negative 1.5 electron volts, and so the difference in energy is negative 12.1 electron volts. The electron has lost 12.1 electron volts. It is 12.1 electron volts lower in energy than it was before. In order for the electron to lose 12.1 electron volts, a photon of energy 12.1 electron volts is emitted. Now you could be asked for the wavelength or the frequency of the electromagnetic radiation that is emitted when the hydrogen atom de-excites from n equals 3 to n equals 1. This is just an example to show you how this works. Well, let's start by calculating the frequency. The energy of the photon is equal to Planck's constant multiplied by the frequency of the electromagnetic radiation. Planck's constant is 6.63 times 10 to the negative 34 joule seconds. However, we have to be careful because the energy is given in electron volts, and in this equation we need to have the energy in joules. To convert energy from electron volts to joules, you multiplied by 1.6 times 10 to the negative 19 joules per electron volt. Alternatively, if you want to convert from joules to electron volts, you would divide by 1.6 times 10 to the negative 19. So step 1 was to convert the energy into joules, which is 1.94 times 10 to the negative 18 joules, and step 2 is divide that by h in order to get the frequency, which is 2.92 times 10 to the 15 Hertz, or 2.92 petahertz. If instead you wanted to calculate the wavelength, you could then use the wave equation, which is c equals f lambda rearranged, and so the speed of light, 3 times 10 to the 8 meters per second, divided by the frequency you've just calculated, would give you the wavelength of this electromagnetic radiation. Well, that's de-excitation. What about excitation? In order to get the electron to be promoted into a higher energy level, it has to absorb exactly the right amount of energy. To excite the atom into the n equals 2 energy level, the electron would have to absorb exactly 10.2 electron volts of energy. Now, if the electron gains that energy by absorbing a photon, it has to absorb all of the energy of that photon, the entire amount. If the photon does not have exactly 10.2 electron volts of energy, it cannot be absorbed. If it has 10.3 electron volts, then the electron cannot be excited by it. If it has 10.1 electron volts, the atom can't be excited, the electron will remain in the ground state in n equals 1. But if 10.2 electron volts of energy has the photon that is absorbed by this electron, then it can be excited to n equals 2. But that's not the only way to excite an atom. The electron can be given energy by absorbing kinetic energy from a particle which bombards the atom. Particles that can bombard the atom include electrons, protons, neutrons, or even atoms and ions, muons. Well, pick a particle. And in these cases, basically anything other than a photon, then either all or some of the kinetic energy of that bombarding particle can be absorbed by the electron that's in the atom. If there is insufficient kinetic energy for the electron to be promoted to n equals 2, then it just won't happen. But as long as the bombarding particle has more kinetic energy than, in this case, 10.2 electron volts, then it is possible for the electron in the atom to absorb some of that kinetic energy and be promoted into n equals 2, exciting the atom. Now, there's a lot to digest here, and I focused on the hydrogen energy level diagram, but of course every element will have its own unique energy level diagram. But the principles are the same. If a photon is emitted, it has an energy equal to the difference in energy level between the final energy level that the atom is in and the initial energy level. And if the atom is excited, it absorbs exactly the amount of energy equal to that difference in energy between those energy levels. We call that the excitation energy. If a photon is the particle that causes excitation, then all of the energy of the photon must be absorbed. If it doesn't have exactly the right amount of energy, it will not be absorbed. But if it is a particle with mass, such as a bombarding electron or proton or even an ion, then as long as it has more kinetic energy than the excitation energy, some of the kinetic energy can be absorbed, causing excitation, and whatever is left is kept by the particle that bombarded the atom. Atoms can be excited and de-excited. Electrons can be promoted to higher energy levels or lower energy levels. And of course, if the electron is given sufficient energy, it can leave the atom altogether. And that amount of energy is called the ionization energy of the atom.